Hi guys, I'm Greg. Today I'm gonna be showing off one of my newest projects, which is like a watch type of thing. You can control it with a joystick, and this is what you need for it. You need obviously a pico. I opted for the W version, the wireless version. You need one of these displays and a battery, battery charger, micro USB version, one of these coreless motors. It's very tiny. It's gonna have some sound capability with one of these piezo buzzers, 2 pieces of Schottky diodes, and a PSP joystick replacement. This is how it looks. There are many versions. You only need one of them, and obviously a USB, micro USB cable that's able to program the pico. Also, you need some tools. You need some screws. And the swear jar comes in handy every once in a while. Also, you need motivation, and yeah, I opted for these things. And the things that I'm modifying here now are the things that you might have to modify on your 3D printer, because depending on, I found that 3D printing doesn't really have the same measurements or specs as your 3D model. So your sides or your placements for things like displays and joysticks might be not fitting into the default that I have for my 3D printer. So you might have to modify those things. Okay, so the next thing is you just grab one of these tools, crunch the middle of it, twist it around a little bit, and it should pop out easily. Around the joystick area, if you see one of these stringy bad 3D prints, get rid of it. And the next thing is grab one of these parts and flip it over. On the back side here, the cross hatching has some support structure that you have to remove. And if you successfully do that, it should look like that, just a tiny dent on the back side. This is important, you have to remove that. So the first step is grab the display. It has 4 pins on the back side. I'll turn it over. And yeah, you have to bend those pins. So yeah, just gently grab one of those and bend it outwards 90 degrees, as I'm doing here. Do that for all 4 of them. You should end up with something like this. And you're gonna place it inside the case this way. So I'm holding the case, the joystick side to the right and the display on the left, and there's literally, you can just click it in place. I'm pushing down the 4 corners. Try not to push down in the middle of the display, because there are some tiny components sticking out of it. You don't want to accidentally remove those, but as long as you push down on the corners, it should be safe for you to place it, put it into place. And now I'm just looking around the display and the case, how they fit together. Basically, I'm looking for a uniform placement. If one of the corners is too deep or too high up from the actual plastic, I push it down. So the next part is you grab one of these joysticks, and we have to remove the circular flat plate under the joystick head, the joystick button head. So basically you can just remove the joystick head with one of these tweezer thingies. Just by force, you just move it upward and it comes off easily. And you have to just poke at this thing. It just flips off easily, and then just put back the joystick head onto the joystick, the thumbstick, whatever that thing called. Yeah, just click it in. Yeah, and this is what we need for the joystick. Yep, looks good. So I'm holding the case again, and I'm showing you guys how you're gonna put the joystick in. So basically, underneath the joystick, these are these 4 soldering pads, and it should face towards you. This is how you put it in, and again, you can just click it in there by force. You just push down on it, and it just clicks into place. So the 4 pins on the joystick and the 4 pins on the display should face the same direction. Yeah, just double checking everything. Yeah, okay. Next thing is you're gonna grab one of these picos, and we printed a plastic part out for it because I'm not sure if you can see, there's a boot select button on the pico. Accidentally, if you push that, it makes the pico, it puts the pico into a different mode. We don't want that. So basically I modeled one of these shapes and 3D printed it out. It basically just doesn't let you, as you can see, I'm trying to push down on the boot select button, but I can't because of these this protection around it, this protection plastic around it. So good, looks good. Next, grab one of these parts, and as you can see, it has square holes. That's intentional. I was too lazy to model a circular hole for it, so, but I found that it's good that it's a tiny bit smaller than the actual screw, because you can manually like widen it a little bit with a screwdriver, and then it basically just, the plastic is so soft, the metal screw thread just forces a new thread into the plastic. So yeah, just do that for all 3 of these holes. It shouldn't be a big problem. And this is how I put it in there. So around the joystick there are these 3 square holes again, where if you put it in this way on top of the joystick, you can, by applying a little bit of force, screw it in, and the screw is gonna actually carve a new thread for itself. And that's, if you push down now on the joysticks, if you push down on the joystick, it's gonna keep it in one place. So next you're gonna need some wires, and I'm soldering some wires to the actual joystick pads. And this is a very finicky job. I did not expect to be this hard. My soldering skills are absolute garbage, as you can see. So this is the horror show part of the video. Anyway, it's really hard, really finicky. Take care not to accidentally solder 2 pads together, and just double check from every angle, and then you're gonna grab it and bend it 90 degrees like how I'm doing now. This is what we want to end up with. And I'm just placing it back into, just testing it if it fits, if there's enough clearance for the wires. Yep, it clicks into place, nice. And if you can, try to adhere to the same color scheme I'm using for the wires: red, yellow, black, green. So black is gonna be always negative, red is gonna be always positive, and the yellow and green are just data. So throughout, whenever I'm using wires and you see a red wire, it's gonna be positive, black one is gonna be the negative always. So next part is we have this area I'm marking and showing now. We're gonna cover that up with some thermal tape. Make a loop like that. We have this plastic part. Stick it to one of the sides and jam it into the corner above the display. Obviously it looks a little bit horrendous. Later on, as I'm doing this video, I'm having it removed and placed anew again. Anyway, just push down on it. You can push down because only push down on the white plastic part, because that area doesn't have any tiny components. It's just a display, the actual display wires. Further down on the display, in the center of the display, we have some resistors and tiny capacitors. Try not to push down on those, just gently. So apply one more tape on top of all that. Gently push down so it keeps the plastic part in place. Like that. Yeah, just making sure it looks nice, and then get another piece of tape, tape it over the motor. I'm using way too much tape here. Try to trim it a little bit, and then you can just place that above the plastic piece that we put down and jam it into the corner over the top there. Yeah. And if you have more tape like I'm having here, you just use a screwdriver and make it come down a little bit towards the motor. Yeah, and then I'm just these tapes are not very gluey. They don't really adhere to anything. The backside of it doesn't really have too much glue on it. Next, you're gonna place the battery, just double checking if it fits there. Yeah, this is the place we're gonna leave the battery in. That's why we have some thermal paste above the display and underneath the battery. Just to keep the display capacitors and resistors on the backside safe from the battery if the battery explodes. I know it's not much, but it's just a peace of mind for ourselves. Next, get another tape. Tape it over the battery. Yeah, you have to juggle these wires. Wires are getting too much. Yeah, just this project uses a lot of wires. Surprisingly, there's way too many wires in this. Grab the pico, and this is how we're gonna put it in there. The left side has a hole for the micro USB port, and we have to align that with the pico micro USB port. So I just put it in there this way, and as you can see, pico is lower a little bit, so I have to push down on the other end of the pico to lift it up, and then I can just move it towards myself, towards the micro USB port. And yeah, I'm just holding it in one place, but at the other end there's a gap between the wall and the pico. I'm just marking it now, showing it to you guys. We're gonna put a plastic piece in there, and that's gonna jam the pico into one place. So just grab this 3D printed part, and by force you can just clip it into one place. Yeah, push down on it. And if you misalign it, try to make it to the center. There's another hole on the right side of the case, and I try to align the plastic bit that we just pushed in there to be roughly in the center, like that. Yeah, looks good to me. I know there's some tolerance issues, but if you try it, the micro USB cable actually fits in there nicely. Yeah, so this is how we're gonna eventually put everything in there. And on the other end side, yeah, on top of that plastic bit, you're gonna put the battery charger downwards, like with all the components facing down towards the pico. And then if you push down on the other end, it should clip into the plastic part, or the other end of the plastic part. Yep, so this is going to be our final assembly, but now we're just going to have to wire everything up. And yeah, that's going to be a little bit tough. We have to take bits out again, and then wire everything together. I think the best thing would be, as I'm showing you guys, we have to do the same wiring on those display pins. But before we're gonna do that, we're gonna wire up, we're gonna modify two of these Schottky diodes. Schottky? I'm not sure how to pronounce it. But basically we're gonna attach these, solder them to the rumble motor. I'm just doing some loops for it. I don't know why did I opted for that. You don't have to do it this way. You can just trim the ends of it and solder some wires to it, but I opted for these loops so I have space for, so I literally have space to actually solder things to it. It seemed a bit easier to me, as again, my soldering is absolute horrendous. I did not have any practice on it, practice soldering. So have two of these. You don't have to have these loops on it. Just leave like 4 or 5 mils, trim the ends of it, and leave 4 or 5 mils space. And next, I'm just holding the rumble motor wires and trying to measure, eyeball it, how much wire I'm gonna need for these. So I just cut it there. Yeah, trim the ends, expose them. So I grab another piece of wire and solder it to this end, and solder the other end to the motor. And I do the same for the blue one, but note the red and blue diodes face different directions, and then I just tape them up so that they don't short circuit as I'm handling them in the case. and I try to tuck them into one of the corners there. So the blue is gonna be the black wire, and the red is gonna be obviously red positive, and the blue is gonna be ground. And I'm just putting back the pico and double checking if it fits in. Yep. Nice. Grab some more wires, trim the ends, and this is basically the main, all the components wired together, wired to the pico. And we're doing now the joystick wiring. So basically the joystick wiring, positive and negative, where they connect to the pico, that connection pin is going to have more components coming into it. So basically I just grabbed one of the wires, exposed a little bit of it, like 2-3 centimeters down, as you can see, and then I soldered, or basically just connected the joystick wires together. So the positive and negative connected like that, and the yellow and green, you can connect them straight to the pico and then solder them. But yeah, so, and then I taped up the yellow and green ones, because nothing else gonna go into those pins. And then I taped up the end wires for the joystick. And next we're gonna have to do the display. And unfortunately, because this was my first time, I did the display soldering inside the case. But first I'm just doing these hooks. And this was a mistake. I think you guys should do it out of the case. So take the display out and then solder the wires outside the case, and then put the display back in, because as you can see, there was not enough space in the case to do that inside the case. So I did a horrendous job here. Oh my god, it's a nightmare for me to look at it. Anyway, so I have the wires sticking out from the display and the 4 wires sticking out from the joystick. Only the joystick wires are soldered to the pico yet. So I'm grabbing the 2 display green and yellow wires and pushing it through between the pico and the plastic protection bit, because it's gonna be on the other end of the pico. Next I'll solder up the wires for the motor, and for a brief second you guys saw the soldering image. So basically the red one goes to the bottom pin, and the blue one, which is the ground, goes 2 pins above it. And yeah, and then next I soldered just 1 loose wire for that area over there, because other bits, I think that's gonna be for the battery charging circuit. Next you guys saw the buzzer circuit, and I just soldered it, yeah, to, mind you, when you flip the pico over, and then when you see the wiring diagram, it's gonna be flipped. So just a warning, on the diagram I have the pico facing towards me with the wireless case on the pico, but here it's on the underside of it. So basically when you look at one of these diagrams, you have to flip it in 3D, because the pico is facing away from you. There's just too much wiring here. I'm not sure how I can reduce that, but basically I've connected up the charging circuitry, and the last thing for me to do is basically just hook up the charging circuitry with the pico wires. I'm showing you guys, yeah, the exposed wire that I did for the joystick is where I'm connecting these two. So I did that, and I think I soldered a little bit, I'm not sure, but I'm sure I taped it up. Yeah, all taped up. And you have to tuck all of these in to the sides, all of these wires, gently, trying not to break any of the soldering on the pico, which is like really hard actually. I was afraid it's not gonna work. Anyway, the next bit is I put some tape around the connections of the buzzer and the back side of the buzzer. So when I put down the buzzer facing the white part up, the back side is not short-circuiting anything on accidentally by touching any unwanted areas. And then you just put the back side in, and you need one of the screws and a little bit, yeah, you guys gonna see it in a second. It looks nice from the front, but when I turn it over, it's a little bit bulging a little bit. Yeah, it shouldn't be doing that, but I think I used too much wires on it. I wasn't thinking how I'm gonna, or where I'm gonna place or tuck away those wires. Anyway, this is what you should end up with. The reason I did it this way is basically the case backside holds everything inside the case. I didn't want to overcomplicate by making the case thicker, thereby allowing components to stick into one place and screw it down and hold it, because then I have to model these holding areas for it. And I'm just more beauty shots of the thing. I've ordered from Amazon. All the components, you can find it on Amazon, except the 3D case. You have to print it yourself. Hopefully you got a printer. If not, mail it to a buddy, and hopefully they can print it out for you. And I've ordered a NATO style watch strap, and it turned out to be too thin for my liking, so I think I'm just gonna redo it later. Okay, now I'm showing you guys the 3D model. Basically, I use Blender for it, and I'm highlighting that there's only 2 layers. The first layer has the actual case, and the second layer has components and bits that we need, the backside and plastic bits. And the things that I'm highlighting and moving around here are things that need to Boolean the actual case. Basically, these are parts that need to carve out shapes from the case. So I'm using the Boolean modifier. Basically, you select the case, select the Boolean modifier, and then the operation change it to difference. And then, yeah, I have these names for these. I'm just highlighting. The case has a name, and the Boolean object, basically. So I'm selecting the A case. I need to Boolean it with the A Boolean. And yeah, carved out nice little holes. Basically, this step is the last step I do on the 3D model, because the placements of these holes might change, or I might get rid of it. It's just too much geometry for me to worry about in while I'm modeling the case. So when you finished with the first case, you have to delete the second layer, because we're going to export it as OBJ file. And for some reason, if you have multiple objects on different layers, the OBJ exporter merges them together. So I only want to export the first layer, and now I'm back to the second layer. We have some Boolean objects on these as well. I'm showing you guys. We need to Boolean these cylindrical shapes again. Basically carve it out from the plastic bits, and I have these numbers and logos for the watch case as well. So basically I have to do 2 times Boolean. One is the cylindrical shapes, apply it, yep, and then you can delete the actual shapes, and now it has some carvings in there. Yeah, nice. Just removing all the doubles from the model. Maybe you don't have to do that. I always do it. I'm not even sure, I haven't checked if there's any problems if you leave those in. And now I'm just doing the second one, which is like the GG Iwatch logo and the 23 number on it. The 23 is supposed to be the reference for the year. So I'm doing this end of November and start of December 2023. So 23 is the last 2 digits of 2023. And then I'm exporting as an OBJ file. So basically you should end up with A object and a B object. A object is the actual case, a B object is just extra stuff like the case backing. And now I'm showing you guys the actual font that I'm using for the number 23. Maybe when you come across this video, it's 2038, so you might have to change the 23, or you want to type your own name in it. So you just create a text object, and under the text object here you can load a font in, and with this file I'm attaching the open source font that I've used for this project. So stylistically at least you can match what I did with this if you want to. You don't have to, but if you want to. So I'm just doing some more stuff and then trying to align it. Yeah, under the font section in Blender you can make the actual font, because as it is now, it's only a 2D plane, it's flat. You can make it a 3D shape by give it thickness. So I'm just playing around with the wording and letter spacing at the moment, and here in depth and extrude you can give it different shapes, and the extrude one is the actual thing that we need. Yeah, give it some thickness like that, make it thick. I also remove some doubles and then scale it down a little bit, turn it 90 degrees, and then I think I'm just gonna place it in the middle, somewhere around the middle, and then give it some more thickness. And yeah, I have to scale it down a little bit more. Yeah, just checking. Yeah, it's about right. I don't want it to go all the way through, so I just want it like how I did with the GG watch or the 23. It's like basically carving a shape out up until the middle of this backing plate. Yeah, I don't want it to go through all the way like the cylinders did, the cylindrical shapes. So you can make it go all the way through and have this as your sound escape porthole things for the buzzer. Okay, so next part is you have those 2 OBJ files. I have a Creality Ender 3 printer, very old, and basically I'm just selecting the standard quality in Cura, which is like 0.2 millimeter wall thickness and layer thickness. and then you just open one of those. Let's start with the case, the A file, yeah, AOBG. And as you can see, if you handle OBG files, OBG files don't have built-in measurement. So that's why I have around the cases or around the 3D models these rectangular shapes, which is basically, that's my base measurement. So I just changed the scale from 10 to 100. So basically that refers to 100 millimeter, 10 centimeter. I'm using metric for this. So inside Blender, I chose one of these grid scales to be 1 centimeter. So I just stick to those measurements. And so because I have 2 layers, I just do 2 of these hollow squares around the object. So whenever I scale them upwards in Cura for 100, it should be 10 centimeter for those 2 layers. So when you print those 2 layers out separately, the bits and the parts inside those squares should match up. So I'm just showing you, if you use a different printer and it has different settings, I'm just showing you some settings that the standard quality automatically selects for my printer, and these are the settings for it. I don't use any build plate adhesion skirts or rafts. I only use support, and I change it from everywhere to touching build plate only. And then support structure normal, yeah, leave it on zigzag, 45 degrees, yeah, everything else stays the same. This part needs some support structures, so the automatically generated one by Cura seems to be fine for me. Yeah, so build plate adhesion, we don't need that. And then just slice it. Yeah, it's about 4 hours, that's normal. I did not go in there and change the speed settings or wall thickness settings. I've just used the standard quality 0.2 mil profile setting in Cura. Seems to give me, whenever I change anything inside, for some reason my printer turns the prints into mush. So I just leave everything on standard quality. So now I save the first layer and I load in the second layer and change the X to 100 again, yeah, and then I can just turn it and place it on the bottom side, yeah, like that. This is how it should be placed, yeah. Make sure you have snap rotation on, so it rotates in, I think in 15 or 30 degrees, I'm not sure. And then just slice with the same settings, standard quality 0.2 mil, layer height. And even though it looks a little bit rough in the slice preview, it comes out nice. And that is 1 hour 40 minutes or so, yeah, that's about right. And it only needs support structure for the plastic bit that clips the pico and the case walls together. Yeah, you have to remove that later on, obviously. And then just save it to disk, yeah, and then you're ready to print. Grab the micro USB cable, grab the pico, and then hold the boot select button down, and as you're holding it down, you put the micro USB cable in, and on your PC, your pico, it comes up as an external USB hard drive. As you can see, it popped up here. You can release the boot select button now, but basically there's nothing on the pico yet. So if you order it from Amazon or the Pi Hut and it comes to you, there's nothing on it. So we have to put some software on it. I use MicroPython. You can use C development environment on it, but Python suits me just fine. You have to go to this address or just type in Raspberry Pi pico W, and this is how it looks. So yeah, so go to documentation and then microcontrollers and then Raspberry Pi and Pico. Click on that, and on this website you have to scroll all the way down, all the way to resetting flash memory, and down here download the UFT2 file. Click on that. It should save it to your desktop or to your documents, save as. Yeah, and then you're just gonna grab it from wherever you saved it to, and then copy, and then click on the Pi, and then you just paste it in here. That will make your Pico to reboot automatically, so don't worry, that's fine. Next, go back to the internet and Google THONNY, THONNY. We're gonna need this for our Python development. Download it, install it, and then you can run it. So basically, first you have to plug in the micro USB to your PC and the other end to the Pi Pico W, and then you can start up THONNY and hopefully go through an installation that automatically detects your MicroPython and sets everything up for you. Sorry, automatically detects your Pico W and sets everything up for you. If not, here in Tools and Options and Manage Packages is what we have to use. But also down here in the corner, you might have to select your Raspberry Pi Pico version. So I'm using MicroPython Raspberry Pi Pico, select that, and then under Tools, Manage Packages. As you can see, I already have that, but if you start from scratch, from a fresh Pico, you're not going to have that for the display. Basically, this is the display driver, and we have to look for it on the internet. So just type in, again, under Tools, Manage Packages, here type in SSD 1306, and then search on PyPy, and choose this one, the first one. Yeah, whatever, and click install. I already have that, so I'm not gonna do it. Also here you have to type in requests, search for it, and then install that one as well, and then maybe try requests, search for it. Yep, MicroPython, install. If you the code I'm releasing for it, it's basically just a short 300-line test code, which is just basically going to make sure that you can run the display, the piezo buzzer is giving out sound, and the motor is buzzing, and the joysticks are actually updating some real-time values. So that 300 lines of code is just testing some stuff. Or it also tests your Wi-Fi connection. Basically, you have to, if you're gonna get any errors, it's gonna be this, that you have to install through tools, manage packages, and then search for it, SSD 1306. You type it in here, search, and install the MicroPython version. And then maybe this and network and uRequests, maybe those libraries, you have to search for these. I'm not sure, I forgot. I'm not sure, because it's already been installed for me. I don't have a second Pico W for you guys to test with, and I already built my only one into a case. You're only, basically I'm testing, it's going to connect to the Wi-Fi. You need a Wi-Fi access point, because it's going to connect to the internet and to these two web addresses. So you have to fill in here your Wi-Fi name, access point name, and then down here inside the double quotes your Wi-Fi password. One of them is it's basically fetching the Bitcoin price, and the other one is fetching the internet from this address. Sorry, fetching the time from this internet address. If you're gonna get a fetching error or a fetching fail message, it means two things. One, your internet connection wasn't successful, or you don't have any Wi-Fi access point available. Two, one of these addresses might change in the future. These are API addresses. I don't control them, so it depends on what these companies giving you as a price checker or a time checker address for you to use. So you might have to modify these in the future, but as of now, 2023 December, those two addresses work. So you have to fill in these 4 things potentially, but definitely these 2 things. And then basically what the code does is just sets up the joysticks, the buzzer, and the motor, and then it displays a neat little message, and then buzzes the motor and runs the motor 2 times and buzzes the piezo buzzer 2 times. Hopefully your wiring was neat and no wires and soldering pin has broken off, so everything works for you. And then it just goes on to basically a main loop, an infinite loop, where it checks for the joystick movements and displays it onto the screen. And then if you move the joystick around, you can see it on the screen updating real time. And if you move the joystick to the left, all the way to the left, I think this is where I define it. Yeah, if you move the joystick all the way to the left, it's gonna fetch the Bitcoin price. And if you move it all the way to the right, it resets the Bitcoin price fetching command. But the way I found it, there's a time limit on it, because the request and the internet connection takes like a few seconds. So the internet connection code basically kind of sort of breaks these inputs. So it takes a few seconds for you to be able to move your joystick to the right and reset everything if you want to. And then if you move the joystick up and down, all the way up, it manually activates the time fetching function. So basically it connects to the internet, goes to that web address, the API gives back a time, and it displays for you that time. And if you guys have some free time on your hands, maybe you could try out my video game on Steam. It's called George McGeehan Gamer Hero. It's a free game. I made it with Python. It's a precision platformer. You have to jump upwards, and there are 100 levels. 100. Just have to button mash the jump button and try to make it up the platforms. And try to beat my time. Mine is around 25 minutes. Basically, you just have to speed run and jump up, up, up. Who has the best time worldwide is the winner of the game. It only works on PC at the moment. If you have a video, a speedrun video of it on YouTube, send me the link under the comments. I'd be happy to check them out and comment on them. Yeah. 25 minutes. Who can beat that? See you guys later.